Welcome to 5G Hub. In this video, we will talk about 5G new radio protocol stack. Before starting, let's discuss first what is the protocol. In general, a communication protocol is a set of rules for message exchange and or sending blocks of data known as PDUs between network nodes. A protocol may define the packet structure of the data transmitted and or the control commands that manage the session. A protocol consists of several levels of functionality. For example, as you see in this image, you can see the OSI 7-layer network model and NR protocol structure. So here you can see different kind of layers. Layer 3 for our radio resource control, layer 2 for SDAP, PDCP, RLC, and MAC, and physical layer. So 3GP consider layer 3 and layer 2 mapped to the physical layer and data link layer. The next generation radio protocols in 5G can be divided into control plane and user plane, where the user plane protocols are typically responsible for carrying user data, and the control plane protocols are used to transfer signaling and control information. Here you can see the higher layer protocol in 3GPP stack are the application and transport layer. So the question now, what is the new protocol in 5G regarding or versus 4G? 5G new radio user plane contains physical MAC layer, as you can see in this image, physical MAC layer, BDCB, RLC, as is like the LTE. However, 5G introduced a new layer named as SDAP or Service Data Adaptation Protocol. On either side, the control plane of 5G is identical to LTE here. For example, MME equivalent node named Access Mobility function. So the SDAP protocol is a new in 5G and are compared to LTE protocol stack. SDAP handles the new quality of service framework of the 5G in the core domain. So SDAP applies also to LTE when to connect it to 5G core network, for example, in some options like option 7, option 4, and so on. Okay. So here, the Service Data Adaptation Protocol, or SDAP protocol, is the difference in the user plane architecture compared to the LTE, and it's introduced to support the new flow-based quality of service model of the 5G core network. With this new quality of service model, the core network can configure different quality of service requirements for different IP flows of a data session. So the SDAP provides mapping of IP flows with different quality of service requirement to radio pairs that are configured to deliver that required quality of service. As you see in this image, this is the G node B and this is the user equipment. This is the SDAP or Service Data Adaptation Protocol. Here we can see a different radio pairs, for example, radio pairer 1 and radio pairer 2. Each one will have its isolated RLC, BDCB, and the MAC layer can give differentiated handling to traffic for different RP2. So here, this is the quality of service framework in 5G new radio. As you see, this is the next generation. For example, this is the next generation RAN access port, and this is the 5G core. This is the user plane function or the entity responsible for user plane. This is the G node B. This is the user equipment. Here is the next generation RAN general quality of service framework, both for 5G connected to 5G core and also for LTE connected to 5G scenario. For each user equipment, 5G establish one or more BDU session. This is a BTU session, as you see. And the next generation RAN establish one or more data radio pair. This is the radio pairer per BDU session. So for each BDU session, there are one or many radio pairers. The next generation RAN also maps packets belonging to different BDU session to different data radio pairer and establish at least one default DRP for each BDU session. And also filters in the user equipment and in 5G associated uplink and downlink packet with the quality of service flow. The access stratum level mapping rules in user equipment and in next generation RAN associate uplink and downlink quality of service with DRP. In 4G, on another side, LTE quality of service is enforced at EPS pair level, but in 5G, as you see, quality of service is enforced at quality of service flow. So we will have a different quality of service flow. And 4G uses EPS pairer, each assigned an EPS pairer ID. Here, 5G uses quality of service, each identified by something is called QFI. So what is QFI? QFI is a quality of service flow ID. Quality of service flow ID. As with 4G LTE, both non-GPR flows and GPR flows are supported in 5G, along with a new delay critical GPR. So 5G will introduced also something is called reflective quality of service. So there are many differences between quality of service handling in 4G and quality of service handling in 5G. And thanks to user play, new protocol is the AB in 5G. So this is for today. Thank you for watching and see you in next video.